Again, this lecture covered the non-parametric tests, and we are going to focus on Spearman correlation. And so our main objective is to use the Spearman Rank Correlation coefficient to determine whether the correlation between two variables is significant. So first, what is a Spearman Rank Correlation coefficient? It's the measure of a strength of a relationship between two variables. So the concept is the same as PSC correlation, where we can find the strength of a relationship between two variables. For example, the values for PSC correlations between -1 to +1. If it's close to -1, we say we have decreasing relationship, which means if one variable increases, the other will decrease. If it's close to +1, we say we have an increasing relationship, which means if one variable increases, the other also will increase. If it's close to 0, then we don't have no relationship between the two variables. So again, Spearman is the measure of a strength of the relationship between two variables. Now it's a non-parametric equivalent to PSC correlation coefficient. Also, Spearman, the data is based on rank we are going to use. So first we calculate using the ranks of a PS sample data entries. We use the symbol R and subscript X to represent again the Spearman rank correlation coefficient. Now, this is the formula we use. Now, we know PSC is a parametric test, so we can find the mean, standard deviation, and the z-score. So normally, if you are going to find the PSC correlation, we have to find the mean standard deviation, and that will lead to z-scores. But with Spearman, our main concern is finding the D, and this is based on ranking. So the formula is 1 minus 6 times the sum of D squared divided by n times n squared minus 1. Now, n is the size of the sample. But here we say that is the number of pair data entries, because again, with Spearman, we have to use two data. That's two variables. So again, we're going to see an example in a few minutes. So D is the difference between the ranks of the pair data entry. Now, the value of RS ranges from -1 to 1, +1. Inclusive means including -1 and 1, same as PSC. Now, if the ranks of corresponding data pairs are identical, then RS is equal to +1. If the ranks are in the reverse order, then R is equal to -1. Now, if there's no any relationship, then R is equal to 0. That's the relationship between the two variables. If we don't have it, then R is equal to 0. Now, to determine whether the correlation between the variables is significant, we can also perform hypothesis tests for the population correlation coefficient, same as again PSC correlation. So the null and also the alternative hypothesis for this test are as follows. Always the claim should be the population correlation, or the rho should be equal to 0. And if it's equal to 0, it means what? There's no correlation between the variables. Then the alternative hypothesis, or HA, will be not equal to 0, which means there's a significant correlation between the variables, always. So this is the steps. So the first thing, this is again a hypothesis testing. So the first thing we need to do is to state our HO and HA. Again, HO is our claim, HA is our alternative. As we said earlier, always HO means there's no correlation, which means the population rho equal to 0. Then we need to identify the level of significance. By default, most of the time is 0.05, the alpha. Then we need to determine the critical value. The critical value, we have to use our textbook table for the Spearman correlation, critical value. And then if we know the critical value, we can find the test statistics, which is the formula we were talking about. Now, if we know the value of the critical value, and also we know the test statistics, then we can make our decision whether we should reject or we should fail to reject the HO. So make a decision or reject or fail to reject the null hypothesis. Now, always, if our test statistics is greater than the critical value, then we reject the HO. By the opposite, we're going to fail to reject H, which means, again, if the critical value is greater than the test statistics, we are going to fail to reject H, which means we have to accept H. There's no correlation between the two variables. Then we need to interpret the decision in the context of the original claim. Now, let's see the example here. So hopefully this example will be everything. So in the example here, the table shows the prices in dollars per 100 pounds received by US farmers for the beef and also lamb from 1999 to 2005. So we have the years here, 1999 to 2005. The price of the beef and the lamb is given for each year. Now, our goal is that we want to find out if there's a correlation between the beef and the lamb price. For example, if the beef price increase, also the lamb price increase, or if the beef price decrease, the lamb price decrease. Now, looking at this data, we may see that there's no correlation. Sometimes beef increase, lamb decrease, or lamb decrease, beef increases. But again, we are going to perform our hypothesis testing to see. Also, the alpha value is given, so it's 0.05. So first we state our HO and HA. Again, HO means there's no correlation. So operation rho is 0. HA will always go against H. So if it's equal for HO, it means not equal for HA. So if it's not equal to 0, then we say that there's a correlation between the beef and the lamb price. Maybe if the beef increase, the lamb price also increase, or if the lamb price increase, the beef price decrease. We know the alpha value is 0.05. We know this sample size. So with the alpha value and sample size, we can find a critical value using the table in our textbook. So the textbook table will look something like this. So we know the N is our first column. Then we have different values for the alpha. In our case, we are using 0.05 and also N is 7. So we get 0.786 for the critical value. So the critical value is 0.786. Now we need to find the test statistics. First, we saw the formula have D, and we already know N, the size of the per sample. And so the main thing is find the D. Now, in order to find the D, we create a table here. We have all the beef price and also the lamb price. Do not change the order of it because they go by yearly. The first row is 1999, second was 1990, 2000, etc. up to 2005. So we didn't change anything. So first we are going to rank the beef price. The lowest price will be 1 and the highest price will be 7. So it's in increasing order. So 63.4 is the lowest. The next lowest is 66.5. The next lowest, the next highest, 68.6. So it's increasing order from the lowest to the highest. So the highest value is 89.7. So that's number 7. Then the second highest is 85.8, number 6. The same thing we are going to do for the lamb. So the lamb, let's see, the lowest value will be 66.9. So that will be 1. Then the rest, again, the biggest value is 110. So that is 7. So now we are going to find the D. Now the D will be the difference between the beef rank and also the lamb rank. It doesn't matter. You can do 1 minus 3 or 3 minus 1. It doesn't matter. You get the same answer. Why? Because after we get the D value, we are going to use the D square. So if your answer is negative, when we square it, it becomes positive. If your answer is positive, when you square it, it becomes positive still. So it doesn't matter. We can say the lamb rank 3 minus 1 or 1 minus 3 because we are not using D, we are using D square in the formula. So 1 minus 3 is negative 2, 2 minus 2 is 0, 5 minus 5 0, 6 minus 6 0, etc. Now we are going to square everything. So we get 4, 1, 9, and the rest is 0. So this means our total or the sum D square will give us 14. Okay, so we are good to go now. We can find the test that it takes. So we plug in the value 1 minus 6 times 14. The sum of this square is 14. N is the sample per size, 7. 7 squared minus 4. So our answer is 0.75. Then we look, okay, 0.75 test statistics. Oh, the critical value is 0.786. This means the critical value is greater than what? The test statistics. So we are going to fail to reject HO. So that means there's no correlation. Fail to reject HO, there's no correlation between the beef price and also the lamb price. Actually, when you look at the data, you see that sometimes the beef price go up, the lamb price go down. Sometimes the beef price go down, the lamb price stay up or down. So just looking at the data, we can see that there's no correlation. So we can put it in our interpretation. We use 5% alpha or 0.05. So we say that at 5% level of significance, you cannot conclude that there is a significant correlation between the beef and the lamb prices from 1999 to 2005. So that's again the steps. Again, if you have any question about these short lectures, you can send an email and hopefully we'll meet in the class next week. Thank you. So in these lectures, again, we learned about how to use the Spearman Rank Correlation coefficient to determine whether the correlation between two variables is significant.